Hello and welcome to another video by Learn Computing with Daniel Bullen, with me, Daniel Bullen. In this video, I'm going to go through the Summer 2022 paper. It is a version 3 via the Cambridge International AS Level Computer Science. But before I do, please remember to click that like and subscribe button, write a comment down below, and keep sharing it and share this video far and wide, especially if you want your classmates to succeed. Without further ado, I'm going to go into the 2022 AS Level Computer Science past paper via the Cambridge International Exam Board. Yep, I'm not going to go for the yada yada yada, because that's what the invigilator will do before you actually put pen to paper, open a paper and put pen to paper. Yep, total mark for this paper is 75. Okay, question 1. Text and numbers are examples of data stored in a computer. So a character set is used to represent those characters. So we need to describe what is meant by a character set. So basically saying, what is a character set? What does it mean? Well, answer you're going to have, a character set is where all of the characters that the computer can represent. So every character will have a unique number. So any unique number, so we mean byte, it could be a byte, it could be so what we mean by unique number, we mean denary number, and it's also going to have a binary number, and it's also going to have a hexadecimal number. Because with numbers we can convert from binary to denary to hex and so on. So it'll have a unique number, so it could be a denary number, it could be a binary number, and so on. That's literally that for the question. Next one, we need to identify two character sets and state one difference between them. So if it was me, character 1 would be ASCII, and the second one would be Unicode. Why? Because there's a difference between the two. ASCII, it has seven bits. So, or I would say ASCII can represent only English, which is true, even though it's not in the mark scheme. Whereas Unicode can represent more languages like Greek, Chinese, Russian, etc. Okay, so it can represent more characters than ASCII. Okay, so we would get 2 marks for mentioning the 2 character sets and 1 mark for the difference. Okay, so that's literally it. So ASCII can only be in English. Unicode can be other languages as well. Or alternatively, you could say ASCII. So you can say ASCII has 7 bits. Unicode is going to be 32. We'll have either 16 or 32 bits. That's literally all we would need to say. Third part, we need to describe how lossless compression can be used to reduce the file size of a text file. So we can use run length encoding, which will identify groups of repeated characters. So what it's going to do, it's going to replace those repeated characters with 1 copy of the character and how many times that character will occur. Okay, so why should lossy compression not be used on a text file? Because none of the original So none of the original data can be retrieved once it has been lost. So if we lose that data, that's it, we're not going to get it back. And the text file would also be corrupted. So meaning we won't be able to actually open the text file, or you could, but you won't actually be able to view the contents that's actually in there. And that's why lossy compression should not be used. None of the original data can be retrieved once it's been lost, and the text file would be corrupted. Next one. So a computer can represent numerical data in different forms. So we've got to complete the table by writing the answer to each statement. So yes, there is a working space, which you can use to your heart's content. So hexadecimal value. So 11, the hexadecimal value 11, when represented in denary, that's going to be 17. How do we know that? Because you would split the two ones into two nibbles. So it would be 0, 0, 0, 1, and then 0, 0, 0, 1. Put that into binary, 16 plus 1, 17, bosh, done. Okay. Smallest number that can be represented in an 8-bit denary integer, 0. If you need to work that out, something's wrong. The denary number 87 represented in binary coded decimal. So whenever you do binary coded decimal, you would do one nibble, and then you would do the next nibble. So how are we going to do that? Right, let's have a look in the working space. We've got 8 and 7. What we're doing, we are splitting. So we are splitting the two numbers, which is why. So 8 in binary is going to be 1, 0, 0, 0. 7 is going to be 0, 1, 1, 1. Why? Why for that one? Because you've got, if there's 0 and 8, 4, then plus 2 is 6, plus 1 is 7. And then for the first nibble, which is your 8, 8 plus nothing is 8. That's why we got 8. So that is why we got 1, 0, 0, 0, and then 0, 1, 1, 1. Okay? Right, 240 represented in hexadecimal. Right, let's do some working. So, 240, we convert that to binary. So do 128, 64, 32, 16, 8, 4, 2, 1. Right. 1. That's going to be 224 plus 16 is 240. Convert that into hex. We know that's going to be 16, 15, which is going to be F. And then that's going to be 0. So, all we do is we just say F0. Done. Right, denary number minus 20 in 8-bit 2's complement binary. Not 2's company, 2's complement. Did you hear that? 2's complement, not 2's company. Why? Because a computer science teacher going for a job actually said 2's company once. But hey. Well, we won't get into that melodrama, but hey. So, you got minus 20. So all you'd have to do, so 20, we know is going to be 0, 0, 0, 0, 1, 16, 8, 4. So that's positive. All we're doing, flip. How do I know that? Minus 128 plus 64, minus 64, minus 64 plus 32, minus 32. And then why they got the minus, and why they got the minus and minus 16. That is taking us to, that'd be minus 16, and then that'd be minus 12. So obviously we would need to we would need to flip the bits and then add the 1 to it. Or we could just flip those bits and leave those alone. That is your 2's complement. Yep, 2's complement, I think, is one of those terrible things they put in computer science, but it's got to be taught. Right. This question is to do with register transfer notations. And yes, it is in chapter 4 of the AS spec. So the fetch execute cycle is represented in register transfer notation. So we need to describe each of the given steps. 1 mark for 1 description. So you got PC, it's PC plus 1. So that means the address in the program counter is incremented, because that's what the program counter does. It increments the address by 1. Where we've got MDR and MAR, you've got memory data register and memory address register for the second one. So that means the data in the address that is held in the memory address register is copied over to the memory data register. And then in the last one, you've got the memory address register and the program counter. So the contents of the program counter will be copied to the memory address register. So that is what these arrows mean. So it means if you go on MAR to MDR, that means we're copying the content, the data in the address held in the memory address register goes into the memory data register. We've got PC and MAR, that means what we have in a program counter gets copied and pasted over to the memory address register. That's literally what we mean. Next one, we need to explain how interrupts are handled during the fetch decode execute cycle, and that's a 5 marker. So what you would need to do, you would need to check for the interrupt at the start of the cycle, at the fetch execute cycle. Then the priority will be checked. So if the priority is lower than the current process, the fetch execute cycle just continues. If, however, the priority is higher than the current process, then the state of the registers will be stored on the stack data structure. And then the location of the interrupt will be identified. And then the appropriate interrupt service routine will be called to handle that interrupt. And then when that interrupt service routine finishes, we check for any more further interrupts that are of higher priority. Otherwise, we're going to load the data from the stack, and we're going to continue with the next fetch execute cycle as if the interrupt never happened. But that's going more than what they want for 5 marks. So you would get 1 marker saying check for the interrupt at the start of the fetch decode execute cycle. Priority is checked, that's 2 marks. This bit will get you your 3rd. This bit will get you your 4th. And that part will get you your 5th mark. So that will still get you 5 marks. Okay, so 3A the table will show part of the instruction set for a processor. So it's got one general purpose register, the accumulator. So you've got your opcodes and your operands and your explanation for each. Don't worry, you will get a table like this if they ask you that question. Every year it comes up. So every year when a question like this comes up, you will get a table with these explanations. So let's say you've got the current contents of the main memory. 101, 67, 104, 100, 68. So what we need to do is complete the table by writing a value that's stored in the accumulator after the execution of each instruction. So where we got LDM, that's immediate addressing, so we're loading a number straight in the accumulator. So in this case, 103 goes straight in there. We've got LDD, that's direct addressing, so the contents of a location at the given address will be going into the accumulator. So it's literally going to be, so 102, so we're going to load 104 in there. And then in the last one, where it says LDI, which is LDI 103, that's indirect addressing. So what that means is that address will be used, will be at a given address. So when we've got LDI 103, you would think, well, that's 100. No, it's not. So where it says 100 here, we would have, that's referencing address 100. So we literally go up here for 100. So we're loading the contents of this second address to the accumulator. So we're getting 100. Like I say, if you've got any questions about this video, feel free to write it in the comments section or give me an email. So, next one, the instructions in part A. So part A, which was this bit, are examples of the data movement group. So we need to describe two other instruction groups. And there are a few of them. So you get 1 mark for saying something like arithmetic operations. So what they do is they will perform addition and subtraction. That's 2 marks in the bag out of 4. Another one you could have, just have input and output of data. And then what that's going to do, that's going to take the inputs from the user and outputs the character of the binary number. So that is 4 marks. You don't need to say both these points, but you can do it just for complete. I would do it for completeness. You could just say takes the inputs from the user, or you could just say outputs a character of the binary number. The reason why I've said both is just completeness. And it shows that you do have an understanding, but you wouldn't get that extra mark. Okay, in the next one, we got a table which shows part of the instruction set for a processor, which is one general purpose register, the accumulator. So we've got your opcodes for your AND, XOR, and OR. So they're your bitwise operations. So we got a binary value 00111101. That's stored in a memory address of 200. Each instruction in the diagram is performed on the data memory in memory address 200. So we need to draw one line for each instruction that will give you the correct result. So let's say I wanted to go into an XOR. XOR. Right. This is how I would do it. So let's say you got 00111101, and I'm going to compare it to XOR 1111. So that would be my mask. So what we can see here, so in an XOR, 0 and 1 is a 1, 0 and 1 is a 1, 1 and 1, that's going to be a 0, 1 and 1, that's a 0, 1 and 0, 1 and 0, they're 1s, 0, 0, 0. How do I know that? Just work out the contents of the XOR gate, so it's going to go in here. And that's our XOR. Okay? Let's work out the OR. So, we're going to use that binary value, and I'm going to do 0, 1, 0, 1, 0, 1, 0, 1. Okay. That's 8 in there. So, we need to have a look at these results. 0 and 0, we know it's going to be a 0. 0 and 1, all of these are going to result in 1s, and then that's going to be a 0, and that's going to be a 1. So the OR is going to go up here, because if both inputs are a 0, the output's a 0. Everything else is a 1. And then we've got our AND, which is going to be that's our 8 1s. So that's going to be a 0, 0, 1, 1, 1, 1, 0, and 1. How do I know that? Because that's an AND. And the AND is going to go up here. As in an AND gate, for the output to be a 1, both inputs have to be a 1. Otherwise, it's all a 0. So that is how I would approach that question. So think about it from a logic gate's point of view. Okay? So I'll put that there for completeness. So that's all you need. That's all you need. And that is literally our answer. Okay? Okay, so a computer has system software, including an operating system. So we need to describe the key management tasks of an operating system. So you would need to describe 2. So, one that springs to mind for me is memory management. And that controls the movement of data between the RAM, the CPU, and the virtual memory, to name three hardware components. That's my 2 marks. So I've said memory management, and I said what it does. Next one I would have, it would be process management. And another mark for saying I decide what processes will be run next. So that will be my 4 marks. You could also have file management. So that's going to create, rename, and delete files and folders. You can have security management, which will create accounts and it'll have passwords in there. It's going to provide all the different utility software and anti-malware, so anything that provides security. You could also have hardware management, so that's going to receive data from input devices, and that will send data to all the output devices, and it's going to make use of the device drivers. And that's question 4A. Part B. This is about utility software. So it's a type of system software, and we need to describe the purpose of backup software and defragmentation software. So you would need to describe the 2. So make 2 points for each. So backup software will make a copy of data regularly, so that if it is lost, it can be retrieved. That's 2 marks for mentioned backup. Defragmentation software will make files occupy contiguous blocks, so it's going to move the free space together, and it will improve disk access times. That is my 4 marks. Okay, for 1 mark, nice and easy, give another example of utility software. You can't have backup and you can't have defragmentation, because that's in the previous question. If you mention one of those two, you're not getting the mark. First other one that comes to my mind would actually be a virus checker. Why a virus checker? Because it will check to see if a computer's actually got viruses, and if it does, we can do something about it. So that's why I would say virus checker. Yes, you can have compression software, disk formatter, disk analysis software, or disk repair. The first one that comes to my mind, virus checker. Question 5. Company wants to store data about its employees in a computer. The owner of the company wants to ensure the security and integrity of the data, so we need to state why the data needs to be kept secure. First one that comes to my mind, prevent unauthorized access. Well, we don't want just anybody accessing our system and getting our resources, do we? Okay. One way the data stored in a computer can be kept secure is by using backup software. So we need to give 2 other ways the data stored in a computer can be kept secure. Run a firewall. And the thing that's coming up in the 2020s, encryption. So encryption, you're scrambling the data, so anybody that tries to intercept it cannot actually read it unless they have a key. Firewall, that's going to stop stuff going in and out of the network. Okay, the data about employees is currently stored on paper, and the data needs to be transferred into the computer. So validation and verification help maintain the data integrity. So we need to identify and describe one method of data verification, that can be used when transferring the data from paper to computer. So if it was me, first one that comes into mind is double entry. Yes, you get that when you're logging in, when you're signing up for something for the first time. And why data entry? So we enter the data twice, and the system will compare them to see if they are the same. So that's the whole purpose of double entry. So when you sign up for the first time, sign up to say social media or anything like that, you make the type in your password twice to see if it matches. Otherwise, you're back to square one. Okay, part 2. Company needs to transfer the date of birth of each employee to the computer system. We need to give one example how each of the following data validation rules can be used to validate the date of birth when it's entered into the system. So range check, presence check, length check. Range check will make sure it is after and before a specific date. So that's what a range check will do. Presence check will make sure that the date of birth has been entered. Because presence check making sure something is entered. We can't just leave it blank. And then a length check, with date of birth, we're going to make sure that at least 1 for day, 1 for month, and 2 to 4 for year are filled in. So basically, it has to be at least 8 characters. No 2 ways about it. Okay? So that's what our length check So length check, make sure it's 8 characters. Present check, make sure date of birth is entered. Range check is specific dates. So it could be between 1900 and today's date. Or you might want to check the month between 1 and 12, or check the days between 1 and the month end. So if I was born in April, so there's only 30 days for me. Some people were born in, say, October or December, 31 days. Okay, next bit. We need to explain why the data in the system may not be correct even after validating and verifying the data. So it may still not be correct because validation checks data is reasonable, whereas verification checks to see if the data matches the data given, and that's actually it. So it's matching to see if the data given matches it. Or we could say verification checks to see if the data matches the data given and not if the original data is accurate. So it's not going to check if the original data is accurate. It's just going to see if what we've given it both times matches. Whereas validation, it's looking to see if the data is reasonable. Okay, 6, relational databases. So a relational database, called technology, stores data about the staff in a company and a computer device used by its staff. So we've got the following tables, staff and device as our entities, and then we've got the attributes in each. So we need to describe the relationship between the two tables. So it's a for marker. So you've got a primary key, staff ID in staff. We'll link to the foreign key, staff ID in device. So that's 2 marks because we're describing the relationships and we're referring to primary and foreign keys in our answer. And then one staff member can have many devices, so that is a one-to-many straight off. And each device can only be with one member of staff, and I would add in at one time. So that is what I'd say. So we've referred to the primary key and we've referred to the foreign key across in their respective tables. And I've basically didn't explicitly say that it's a one-to-many, but you can infer that one staff member can have many devices. You can infer that this is one-to-many. And then each device can only be with one member of staff at one time. Okay, so the database uses data definition language and data manipulation language. So we need to complete the SQL script to return the number of devices stored in the database, the staff member with the first name Ali and the last name Khan. So we need to select count, so that's staff ID, and we're going to get that from the staff table. And then we've got the inner join device on staff ID is equal to device staff ID. In the where clause, first name is Ali and last name is Khan. So it's count staff on and. That's literally it. Okay, the table device needs a new attribute to store whether the device has been returned by the staff member or not. So we need to write SQL to insert a new attribute into the table device. So we need to insert a new attribute. So we would need to alter table device, and then we're going to add returned, and we're going to do that as a boolean. So boolean is true or false. So think of it as, how does a politician not answer a question? They don't say yes or no. So think of boolean as yes or no, true or false, done. Okay, so we've got database is in third normal form. So we need to describe the three normal forms. First normal form, there's no repeating groups or repeating attributes. Second normal form, all attributes must be fully dependent on the composite primary key. And then in third normal form, for our final and third and final mark, all attributes must be fully dependent on the primary key and no other attributes. So what that means is we cannot have non-key dependencies and no transitive dependencies. So those answers will get you 3 marks straight off the bat. First normal form, you don't want repeating attributes. Second normal form, you got to do everything from the first, but attributes have to be fully dependent on the composite primary key. Third normal form needs to meet the requirements of first and second normal form, but the attributes have to be dependent fully on the primary key and nothing else. Okay, number 7. We need to write a logic expression for the following logic circuit. So let's break it down. So we're going to have A. So I would do X equals A and B. Done. And then what we need to have, we're going to need to have an XOR. So I would put the A and B in brackets. Then we're going to have an XOR. So that's going to be not C and B. Why? Because you've got an XOR gate over here towards the end. We've got an AND gate, so A and B, that's fine. Then we got the XOR, which is going to be not C and B. And that's our 3 marks. So 1 mark for again A and B, 1 mark for just saying XOR, and the other mark for saying not C and B. Or you could say B and not C. Doesn't matter which way. Okay, now we need to complete the following truth table for that expression. So X is A and B or A and not C. Right. So as it's an AND, that's going to be a 1. That's going to be a 1, 1, 1, 1, 1. So all that's going to be a 1, and that's going to be a 0, because we've got A and B or A and not C. So it's all going to be 1s and down to the 0. Okay? For 2 marks. Okay. A company uses cloud computing, so we need to define what cloud computing is. So that is accessing a service on a remote server. Then we need to state what is meant by private and public cloud. Right, private cloud, computing services offered by a third-party provider. So public is computing services provided by a third-party provider over the public internet. Whereas a private cloud, it's going to be only available to select users and not the general public. Right. Next one. Give two benefits, one drawback of cloud computing. So, we can access it anywhere with internet access. Very important point to say with internet access. And we do not need to perform backups, because when you are on like Google Drive or anything like that, it just saves for you automatically. You can easily share documents, you can have multiple people working on the same document at the same time, no problem. But there are some problems. You cannot access it if there is no internet access. And it's reliant on someone else to back up, and it's reliant on someone else for security. And you cannot access it if the server's down. And those are some of our benefits and the one drawback that we need. And that is all of them. That's all the questions. So, if you like this video, please remember to click that like and subscribe button and share the video far and wide. Get everyone else to watch this, especially if you want them to pass their grade as much as you do. So that is it for the June 2022 AS Level Computer Science Paper 1 version 3. And I look forward to seeing you on the next video. Goodbye for now. So please be sure to hit that like. And please also remember to hit that subscribe button. And another way to subscribe is to just click on this link, which is below each video I place. And if you like my content and you want to find out more about what I do, I've also got an online course called Introduction to Computer Systems on the Udemy website. So you just need to click on it. And there we go. So this is my online course, Introduction to Computer Systems. So this is the landing page for that course. So in it, you will learn. So these are some of the things we'll learn, like explaining the role of the central processing unit, describe the components of the CPU, provide an introduction to assembly language, which is low-level programming, explain the factors that affect the performance of the central processing unit, and I've also put in another bit that I'm interested in, the physics of overclocking the CPU, which may me develop an interest in electronics and also physics. So there's a lot more to it than even we realized. So this is the course content. So you've got computer systems, so I'm introducing you to it. Then I'm going into the different forms of architecture and assembly language. Then I'm going into the factors that affect it and the physics of overclocking the CPU. And then I'm going into logic, so combinational logic systems, making the logic gates, sequential logic systems, semiconductors. Then I go into all things binary, where we introduce you to number systems, all the way down to doing binary and sound, images and text. And then finally we got input and output devices and the different forms of storage, so that's where memory will come in. And then my assessment is basically one big quiz of 30 questions. So you don't need any knowledge to do this course. All you need is a computer with stable internet connection. So that's all you really need there. And why you should do the course? Well, wherever I don't know, I'll go out and learn it. So the way my brain is wired is I'm on the autism spectrum. So it will be an asset in helping you get through the online courses that we provide. So we understand how to explain things in simple terms, due to my teaching background. So you could think of us as a real-life version of, say, a Sheldon Cooper from Big Bang Theory, minus the rudeness, or a C-3PO, but without the glitches. So, I'm on the autism spectrum, so we're on the autism spectrum and have a rough idea on how to talk to them and relate to them. And my teaching style is that style I've crafted, and one that works in a way that some people don't get if they only had tuition in the classroom, or just want to study the subject a lot more. So this course provides you with the opportunity to go further than you would in the subject that you want to pursue. So those are some of the reasons why you should consider buying this online course, because once you buy it,